Hey everyone, welcome to the Blissy Being. Today we are going to solve the problems using Thevenin's theorem. The question has asked us to identify the current and voltage through 24 ohm in the given circuit. Since we want to determine the current through and voltage across 25 ohm resistor, our first step is to disconnect 25 ohm resistor from the original network, resulting the network. Let's draw it, and our network will be that's how our circuit will look like. Since we want to determine the current through and the voltage across the 25 ohm resistor, our first step is to disconnect 25 ohm resistor from the original network. The resulting network is shown over here. Then we have to determine VTH and RTH. Now let's determine VTH. Since the circuit is open, you can notice that in order to identify VTH, all you have to do is just remove the load resistor. For now, our load resistor is 25 ohm. That's why we remove the load resistor, and our task is to identify the voltage across the terminal A, P. There is no current in R2. No current will flow through this resistor, but 10 ohm, which was R2 previously. That's why there was no current, hence there is no voltage drop. There won't be any voltage drop in this section of the resistor. So now our voltage drop will be, or VAB, for now we can say VAB will be equals to this resistor into current flowing through it, which will be, if the current flowing through it be I1, then the voltage drop will be R3 into I1. Okay, our task is to identify the current. You can easily notice that R3 is as it is, R3 into I1. If this section is open circuit, it's of no use, then the current will be flowing through this will be Vs upon R1 plus R3. Now substitute the value. R3 is 10 ohm into Vs is 20 upon 10 plus 10. Okay, so the voltage drop across AB terminal will be 10 volt. That's how you can identify the voltage drop. After identifying the voltage drop, next task is to identify the RTH, or determination of RTH. Now let's part it. RTH. In order to determine the RTH, all we have to do is we have to short circuit the 20 volt. Now let's short circuit it and draw. That's how your circuit will be. Now from the given circuit, you have to identify the RTH. In order to identify the RTH, you can easily notice this. In RTH, what happened? We have to start from this end. We can see that 10 and 10 ohm, this 10 ohm and this 10 ohm are in parallel with each other. That's why 10 is parallel with 10, and the resultant of those will be in series with this 10. Therefore our RTH will be 15 ohm. Okay, once you identify the RTH, you have to draw the equivalent, Thevenin's equivalent circuit. Now let's draw the Thevenin's equivalent circuit, which will be VTH is equals to 10 volt. Okay, RTH is equals to 15 ohm. Now your RL, which was given in the question, was of 25 ohm. After identifying the Thevenin's equivalent circuit, now determine the current flowing through 25 ohm. Now current flowing through 25 ohm, this will be the current I. Now I will be given by I is equals to VTH upon RTH plus RL. Our VTH is of 10 volt and then 15 plus 25, which will be 0.25 ampere. Once you identify the current across the 25 ohm resistor, you can easily identify the voltage. V will be I into RL, which is equals to 0.25 into 25 ampere, and our voltage will be 6.25 volt. That's how you can identify any voltage current using Thevenin's theorem. Hope this video is helpful for you all. Thank you. Like, share and subscribe. Blissy being.